we are going to take what we know, our knowledge about place value, and we are going to apply it to powers of 10. So our number system is base 10, so everything's 10, 10, 10, 10 this way, 10 this way, 10 this way. We're going to talk about what it means, and it shouldn't be anything too, like I said, exciting, like, whoa, mind blown, because we've been talking about it for all last week. You should be able to read this, your little strip of paper that you have, so you should be able to read that and be able to fill in the blanks based on some clue words that are on here. So some clue words are things like times in this sentence. If we see the word times, are we talking about the smaller value or the bigger value? And when we're talking about those values, is the small value on the right or is the small value on the left? Think about ones and tens. Is the one on the right or is the one on the left? We'll find out, won't we? In this one, we have of. This means what? Times means multiply, of means multiply. Well, when we say of, we're talking about wholes or parts based on our sentence frames that we used last week. We're talking about parts, right? Well, when we're talking about parts, are we going to talk about the small value first or the large value first? And which side are those on? If you guys don't know, this is your left and this is your right. Okay? Now we're going to read these and fill them in. This says, each place value in a place value chart has a value that is blank times the value of the place to its blank. Well, if we're talking about times, are we talking about the whole number or the fraction? We're talking about the whole number. So if we're talking about the whole number, are we going to have 10, 100, 1,000 here? Or are we going to have 1/10, 100th, 1,000th here? We're going to have 10. Because each place in a place value chart has a value that is 10 times the value of the place to its what? To its left or to its right? Talking about your hundreds house, and we're looking at our tens place. Each place in the place value chart has a value that is 10 times the value of the place to its what? Is this 10 times greater than ones or 10 times greater than hundreds? Tens place is 10 times greater than our ones place. So our ones place is which direction on our place value chart? It is to the right. So we're going to say each place in a place value chart has a value that is 10 times the value of the place to its right. Isn't that true? Isn't this 10 times greater than this? Isn't the hundreds place 10 times greater than the tens place? Yes, because the place on the left is 10 times greater than the place on the right, no matter where you move on the place value chart. As long as you're looking down the place value chart and not up the place value chart. Okay? Now we're on to the next one. Each place in a place value chart has a value that is blank of the value of the place to its blank. Well, what we already did up here, we should be thinking about. Are we going to use 10? Does that make sense? Each place in a place value chart has a value that is 10 of the value of the place to its blank. No. No, it doesn't. So if we have a whole number up here, we're probably going to have the what down here? A fraction. And we're going to say 1/10 because we're only talking directly next to it. So when you look at this chart right here and we're talking about the tens place, Each place in a place value chart has a value that is 1/10 of, meaning multiply. So we're getting smaller because we're multiplying by a part of a whole of the value of the place to its what? Is 10 times smaller than 1? Or is it 10 times smaller than 100? Meaning it's 1/10 of the value of 100 or 1/10 of the value of 1. Which one is it smaller than? Because we're getting smaller. Is 10 smaller than 1 or smaller than 100? It is smaller than 100, meaning that each place in a place value chart has a value that is 1/10 the value of the place to its left. Okay? I want you to pause the video, and I want you to pause the video and do exactly what I'm going to say. I want you to repeat this out loud and think about what it means. Don't just say it because I'm asking you to. You have to think about it so that you know what you're talking about. Go. Now that we recognize that the place to its right is that the number or the place value is 10 times greater than the place to its right and 1/10 the value of the place to its left, we're going to talk about what that means for us. So I'm going to give you, this is going to be written in between the two things that you glued in if you glued them in correctly. This is going to be, I'm going to give you the number 1 million. So you're going to write this down too. Because you're writing everything I write down because those are the anchor chart rules. So we have 1 million. And I know it's 1 million because the 1 is in the millions place. This equals what? If I just, what are the factors of 1 million? I don't want all of them, okay? But I want us to think, what's a factor that always is repeating itself to get to 1 million? It's 10, right? 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. 10,000 times 10 is 100,000. 100,000 times 10 is going to be 1 million. So we are going to write out how many times? We have 10 times 10, which is 100. Then times 10, which is 1,000. 1,000 times 10 is 10,000. 10,000 times 10 is 100,000. 100,000 times 10 is 1 million. So 10 times 10 times 10 times 10 times 10 times 10 equals 1 million. If I asked you to write like our hundreds, tens, thousands, 10,000s in this, is that something you'd want to do all the time? Do you think you might make a mistake if you had to write out 6 tens? Say we go to 1 billion. You got to add on 3 more. Is that something you'd want to do? Or do you want to work smarter, not harder? What we're going to talk about today is powers of 10, okay? So we had to do all this reviewing so that you knew we were on the same page, kind of, I hope. I don't know. Guess we'll find out when we come back. But it's called powers of 10. So there's a simpler way to express this. And it looks like this. Ten to the 6th power. That's how many of you guys have ever seen a number with a little tiny baby number writing on its shoulder. This 10 to the 6th power means this. I want you to pause the video so you can do some thinking. And I want you to think about why you think this would equal this. What key parts would be happening here that would give us these kind of numbers, okay? So I don't know what you thought about because I can't see you, but I'm going to tell you what it is. 6, this is called our exponent. It's the baby number that rides on the shoulder. 6, look how many times I have 10. How many times do I have 10? Once, twice, 3 times, 4 times, 5 times, 6 times. 6 and 6 are what? Equal numbers. They're the same number, actually. So I have exponent 6. Well, I want us to look at now a million. How many zeros do we have? Six. So 6, and this only works for 10. Okay, it only works when our base number, our big number, is 10. If I give you 2 to the third power, that's not what that means. It doesn't mean that you're going to get 300. Okay, it only works for 10 or 200. Okay, so our 6 represents how many tens we used. Or if we're looking at our whole number that we got, how many zeros there were. First, we're going to talk about what our base number is. Our base number is the number that is repeatedly multiplied. Isn't it repeatedly multiplied right here? So it is repeatedly multiplied. It is one number, so it's not like 1, 15, 17, 27, like it's not random numbers, it's one number. So it's the number that's repeatedly multiplied. Okay? Our exponent the tiny baby number that rides on its shoulder is the number of times the base number is a factor. Meaning it is a factor 1, 2, 3, 4, 5, 6 times in order to get this. So now that we know that and we see a 10, we're only talking about 10. We will see other numbers with them later in the year, but we're only talking about 10. When we see 10 on here, we know that we're multiplying 10 however many times the little exponent says. So if it says 6, we're multiplying it by itself that many times. We are never, ever, ever, ever multiplying 6 times 10. 6 times 10 does not equal a million. So we don't do that. Okay? So it has to be 6. It has to be 10 6 times. So you guys have a flappy guy that we're going to fill out. Mine, I don't have one, so you're going to write underneath the one that I write, you're going to write the answer and what it means so you can see it. Okay? You're going to write it in expanded, like pulled out all the tens and then what it equals 1 million. It's not all going to be 1 million. But our number, our first one says 10 to the first power or 10 to the power of 1. So those are the ways that you can say it. 10 to the first power or 10 to the power of 1. This equals 10. If you remember last week, I told you that every single whole number has an exponent of 1 above it. That just means it equals itself. Then we're going to have 10 to the second power. 10 to the second power. Does that equal 20? No. Because we never multiply. No. It equals what? It equals 10 times 10, which equals 100. So you're going to write these parts underneath your flap. We have 10 to the third. We don't multiply. So what we do is we take 10 times 10 times 10. 10 times 10 is 100, multiplied by 10 is 1,000. And if you're paying attention, do you see how this has an exponent of 1? That means I have how many zeros? This has an exponent of 2, that means I have how many zeros in my number? This has an exponent of 3, it means I have how many zeros? Am I finished? We have 10 to the 4th power, and that equals 10 times itself, how many times? 4 times 10, that's 2, times 10, that's 3, times 10, that's 4. 1, 2, 3, 4. 10 times 10 is 100, times 10 is 1,000, times 10 is going to be 10,000. How many zeros should there be after our 1? 1, 2, 3, 4. Then we come over here and we look at Then we come over here and we look at 10 to the 5th. If you had to guess, what number do you think it is? Like, what do you think the number is? Based on 10, 100, 1,000, 10,000. What do you think this number will be? It's going to be 100,000. Doesn't that follow our pattern? Remember, math is just a bunch of patterns. We have 5 zeros and 1, 4 zeros, 4. Well, how many times do we multiply 10 by itself to get this? 10 times 10, times 10, times 10, times 10. 1, 2, 3, 4, 5. 5 times, just like our exponent told us. Then we have 10 to the 6th, which equals what? $1,000,000. And that is 10 times itself how many times? 6. 6 times, we should have 6 zeros. When we see a base number with a number on top, on its shoulder, writing on its shoulder, it means that we take this base number and we multiply it by itself that many times. When you come back, you're going to need your whiteboard and your marker, okay?